Today, we're going to modify a servo for continuous rotation. Come on in. Welcome back to Maker's Digest. Last week I showed you how to connect a servo to a Raspberry Pi and an Arduino. This week I'm going to show you how to modify a servo for continuous rotation. People like to use these in robotics for drive motors since they have a built-in speed control, and all you have to do is connect it to your Raspberry Pi, Arduino, or whichever controller you're using. So let's jump over to the workbench and get started on the mod. To modify a servo for continuous rotation, there's a couple of features inside the servo itself that we have to defeat. The first one is a mechanical stop. That's a pin that's on the output shaft gear, and as it rotates, it'll hit something and stop. It's also there so it doesn't just break the potentiometer in half. And the potentiometer is the other thing that we have to modify. In this case, we're just going to remove it. The potentiometer is directly connected to the bottom of the output shaft. So as the motor turns, the output shaft turns, it twists the potentiometer and tells the integrated circuit exactly what angle it's in. So we're just going to get rid of that completely. And if you remember, a potentiometer is a variable resistor. So we have to add some static resistance back in across those 3 pins. The next thing that we have to do to get started on this is take these screws out. So let's get started. There are 4 screws on the bottom of the servo, and they're very long. And if you can see here, there is a bottom cover, the body itself, and a top cover. These screws go all the way through and screw into the top cover. That's why there's only 4. Take it out and this whole thing will come apart. Let's get at it. Okay, now we've got that apart. Let's see what's inside. Okay, that comes completely off. And here you can see what is inside the servo. Let's get you a better look at that. So we can see the motor here and the integrated circuit that's inside. So we're going to leave the motor intact, but we're going to need to pull the integrated circuit out. Let's have a look at the gears on top. So this top portion should just come off, and it did. And so there's the gears, all metal gears on this servo. It's a real cheap servo, but still, metal gears, pretty cool. They're all kind of just sitting there, and you can see right there is the pin that we have to remove on this guy. So it looks pretty complicated. There's a lot of gears. There's 1, 2, 3, 4 different gears, and if you don't remember exactly how they come apart, it might be kind of tough. So a little trick that we're going to do here. So we're going to get our phone, because everybody's got one of these, I'm pretty sure, and just take a picture so we can reference that later when we're reassembling. All right, let's take these off now. I didn't see where that one came from, but we'll figure it out. And they're pretty greasy. You want to try to keep all the grease on those gears, because if you don't have extra grease, you can't put it back on. So here's the gear for the output shaft. This comes right off. And then this gear in the middle has a pin. You can see that sticking up right here. That pin is greasy. But this is what I was trying to say. That pin is not attached to the gear. It just sits in here and allows the gear to rotate on the center point. Put all those over there. So first thing we're going to do is remove this pin. And if you don't have a vise, you get your rusty, crusty pliers out. Find something pokey that will fit through there, and something with a little whack force. Give it a little tap, and it came out. All right, rusty pliers, go back over there. There's that. That's the little pin. He's out. And we have disabled our first feature. Now the second one is obviously trickier. It is the potentiometer that's in there. I happen to know on this type of servo, if it doesn't just pull right out, it's kind of stuck in there somewhere. You can see right here, there are two slots that we can push something in that will try to push that potentiometer out. Because I tried to pull this out and it won't come out. So let's try that. There it is. Didn't take too much force at all. And now we have the integrated circuit coming out with the potentiometer attached. Better turn on my soldering iron because we're going to have to desolder these 3 pads right here to get this thing off of there. To desolder this, we're going to need to hold it in place somehow. Most people have helping hands, but I have soldering Cthulhu. Yes. Oh, soldering Cthulhu. How helpful you are. And I know there's going to be somebody out there who's going to say, but Caleb, that doesn't have it nearly enough tentacles to be a Cthulhu. Whatever. Fine. Other than I've read everything Lovecraft ever wrote, so I can call it a Cthulhu if I want. All right, so this probably isn't going to be pretty, but that's how I do it. Bear with me. I can do this without it. Done. Easy. That's a tiny potentiometer. We're going to keep that because we can use it for something else. Profit. Put you away. Next, we have to build our static resistance. And we're going to use two 2.2K resistors, and we're going to connect them together on one side, flip that over so there's 3 prongs, one resistor up, come down into the center, the other resistor up, connected, and come down. I'll draw something that'll go up here somewhere so you can see what that looks like. For now, we're going to solder that together. So where are my 2.2K resistors? They're over here somewhere. There we go, 2.2K. So this is my resistor storage system. I will show you guys how this all works one of these days. But for now, we just need a couple of resistors. So what we're gonna do is we're gonna take two resistors like this. I'm gonna kind of cross them together a little bit in some way and fold one of these down so we have pin on this side, and the middle pin will come down from the top of these two. I'm gonna need my soldering Cthulhu for this, so I'm gonna put this off to the side for a minute. Shoot over there. And let's see. Bend that over a little bit. Bend that back so we've got a little bit of an S shape in there. See that? And then we want to solder them together at that one point in the center. So maybe I'll take this, bend that over just a bit. There we go. Let's see if we can, these are Cthulhu tentacles here. Or just the reason they're here. Now we're just going to put a little dab of solder on there. I'm going to have to hold this up a little bit with my pinky. Plenty. Okay, so we can clean that up a little bit by clipping one of those leads off that we don't need anymore. And we're going to clip that one off. We'll take the center lead and bend that down. So it's in the middle. Fold that over. And there is our static resistance. So can you see that? Yeah, let's solder that on. Put this back in. And so we want the resistors to be on this side because there's a void in there where there used to be a potentiometer, but there isn't anymore. So we will clamp this in here this way. There's already enough solder in there that we can probably get away with it, but I'll add a touch more. And we'll trim these off after we get this on. And we want to give it a little bit of room so we have the ability to bend these over when they're up. So don't put them right down on the deck. Push them up a little bit. Let's see if I can angle that so you can see it a little bit better. Okay. See that any better? Yeah. So remember, not down on the deck, up just a little bit. Also, these have a little slot in it. It's not a hole drilled all the way through. It's a slot that comes all the way out to this edge. That makes it easy for getting one of these in there. Once they're in, we'll put a little more solder on it. So it wraps all the way around. Okay. There's that. We can clean up these bottom bits. Keep track of these guys because, you know, end up choking to death on one of these days. So many of those in my life. And now we'll just bend this over. Something behind it, so we have a little bit of force. And that should be good. Now we just need to reassemble the servo. So let's take it out of here. Say thank you to Soldering Cthulhu. You have done well, but now it's time to go back to the abyss. Clean up our tools. We know where they are. And now we can just squeeze this back in till it's in a good place, because remember it was held in there before by the potentiometer wedged in with those little clips. So it's just going to rest in there for now. Now we get to reassemble the gears. Let's look at our picture and see how they went. That's right in the center. We have our greasy little pin. It's going to go through there into the hole. And motor. Make sure that sits down all the way so these gears connect here. Now we have our modified output shaft that does not have the pin anymore. And so now you can see on the bottom where the potentiometer connected in there, it's a little slot. So it doesn't really matter where it goes now. Pop that in. Gear on top. Fits nice and snug. And this ring is just some kind of bushing that sits right there. Now everything is greasy. We didn't remove too much grease, so I don't have to put any back on, but I could clean it all up, put some white lithium on there, but it should be fine. Take the top cover, pop that back over everything. It should seat nicely so there's barely a seam there. And on the bottom, when we're putting this back on, we just want to make sure that we get the wire grommet into the little slot. There it is. Screws back in. By the way, these things, super handy. You can have them from Harbor Freight for a couple of bucks. There's nothing really that can go wrong with it. It's a dish with a magnet on the bottom, so when you put a screw in there when you're working on a project, it stays in there. And you know where they're all at. So they come in like a 2 or a 3 pack, pick them up and just keep them around. Don't keep stuff in them so you can grab it when you need it and use it. And there it is. There's the modified servo. Took about 20 minutes or so, not too bad. And the next thing we're gonna do is look at the software. If you've seen the previous video where we showed you how to hook up a servo to an Arduino and a Raspberry Pi, we're gonna do something similar, but the code is a little bit different because when you're setting an angle on this, it's gonna tell it how fast and what direction to rotate in. So let's move on to the software section. First one we're going to look at is Arduino. We're going to do Arduino and Raspberry Pi. First one's Arduino. We're going to hook it up with external power because it's a little bit larger servo. And if you want to learn how to do that, check it out. There's the previous video. We go through everything about connecting this guy. Oh, yeah, that's right. We're doing external. I just said that. Common ground. We'll talk about that in the other video as well. Control signal. A0. Get these out of the way so you can see. Okay, let's pull up our sketch here and have a look. So the way this is working in Arduino anyways, and it works the same on a Raspberry Pi, but it's just totally different values, so we'll talk about that then, is for continuous rotation servo, it takes a value from 0 to 180 just like a regular servo. But now it will reverse direction on either side of 90, which is center, or stop now. 0 will be one way and 180 will be the other. However, since our resistors that we added don't exactly center it, we need to figure out what the stop value is. And on a commercial continuous rotation servo, there's usually a little set screw in here that it's another potentiometer that you can turn with a screwdriver to set the resistance a little bit different for 0. So on your sketch, it will always be 90. But ours might be 92 or 93. But the sketch, what's going to allow you to do is change that number via the serial console until you figure out what it is. So let's just go through this real quick. So we include our servo library. We instantiate our servo object, pin 14, which is A0. We're going to say center is 90 to start with. In our setup portion, set pin 14 to output, attach pin 14 to that servo object, and tell us that we're ready. In the loop, we're going to tell us we're setting the center to center, which is 90. We're going to write to the servo 90 and see if it turns. If it turns, then we know we need to modify it a little bit. We're going to read in some of the value that we type in through the serial console and then set it to center, wait for 1 second so it gives it a chance to turn, loop through, tell us what the new value is, and then write it to the servo. So let's fire it up and see what happens. I'm going to be surprised if that's exactly right. What did I set that to? 19.2? Center 90. Let's try 95. Okay, there we go. Ah, that's right. We're going to stop this by uploading our blank sketch. When you're doing this, don't forget to set this to no line ending, because what just happened was with a carriage return, we sent in 95, it turned it to 95, but the next time around, it read the line ending and it picked it up as a 0. So, no line ending. Back in. So this is interesting because I did exactly one of these servos earlier so I could make sure I was showing you guys the right thing. I did the exact same servo with the exact same resistors, and it was not 90. It was like 95 or 96. I don't remember which one it was, but this one stopped as 90. That's pretty cool. So now let's try to put 95 in there and see what happens. Okay, so now we're rotating pretty slow. Forward. If we go all the way to 180, that's going to be full speed in that direction. We go to 0, it's going to reverse direction, full speed. If we want to stop it, we set it to 90. Pretty easy. So those values probably are not 180 is full and 0 is full. You're going to want to use the same program to determine exactly what those values are. So I mean, if we did like 50, seems the same speed as 0. So let's go up to 60. That slowed down just a little bit, I could tell by the tone. So 55. And I heard the pitch shift just a little bit, so it slowed it down just a little tiny bit. If we go to 70, we're probably going to see a significant change. There it is. So the range that that's usable is 90 to about 50. And the same is going to be on the other side. So if we do 100, 120, 130, a little bit faster, I heard the pitch shift, 140, tiny pitch shift, 145, no change at all. So it's probably 143 or something. And just play with this and figure out exactly what your ranges are. You can set up some kind of interpolation to set speeds or do something like that. But once you know, all right, shush. Once you know what the ranges are and what your center value is, you can run Arduino code just by writing to the servo what that number is. So if you want to stop it, write it to 90. If you want it to move forward, go higher than 90. If you want to move it reverse, go lower than 90 for whatever your range is. All right, again, that's the easy one. Let's move on to the Raspberry Pi. For the Raspberry Pi, we need to hook up the servo. Again, we'll go through that in detail in our previous video, connecting servos to Raspberry Pi and Arduino. Put a link up there somewhere. We're using external power. Again, it's a larger servo and kind of have to with the Raspberry Pi to do so safely. We're going to connect to GPIO 18, which is 6 down, closest row to me. 1, 2, 3, 4, 5, 6. And goes into control. And our common ground. 3rd pin, closest row to me. Common ground. All right, let's fire up our example. So we're going to use the GPIO module for this example. We're going to skip the wiring pi because you already saw how to do that, and it's basically the same. You'll remember it's just a little bit different values. Very similar to what we did with the Arduino sketch. Tried to duplicate it here, but it's a little bit different because we don't have the serial console, so there's two modes that this runs in. If you run this without any arguments, it will go into an interactive mode where you can try to find the center in your high and low values. If you run it with an argument that is a number, it will rotate the servo with that value. All of that is described in the README on GitHub, so be sure to check the link below and see all of this code and the description and instructions on how to do that on GitHub. So real quick, we'll go through this. Import our GPIO module, time from sleep, and actually we don't need this. I'll take that out. We don't need that either. I'll remove that. So we're on pin 18. A little bit delay in there. I don't know that we're using it. We're setting up our servo. Our servo object is GPIO PWM, pin 18 and 50 Hertz. We start it. And here's our center or stop, whichever. And last time I ran this, it was at 7.31. That's the duty cycle. So in order to change this, we call the method change duty cycle with a number in the range we're going to find by doing a little bit of calibration here. And the center on this one is 7.31 with a range of plus minus 2. So passing 5.31 is max speed in one direction and 9.31 is max speed in the other direction. If you give the method a number anywhere between there, the servo will rotate at a slower speed in that direction. So this is, oh, I guess I do need that. That's where this is. I don't need get opt. So we're going to read in the argument. If the argument exists, it's just going to change the duty cycle to that speed, spin it for 2 seconds, and then bail. Elsewise, we're just going to continue in a loop while true, print using value, center, change it to that center, read in a new value from user input, set center to that number, and it's a float, so we have to set that, loop back through, and just continue doing that. Let's have a go. Sudo Python GPIO example. And it's the same as we saw in the Arduino. The last servo I did was 7.31. Not the case on this. So let's enter a new value and see what we get. Let's do 7.5. That's where it should be. Nah, it's sped up. Let's go the other way. 7.0. Nice. It is a flat, even number. Or a decimal point anyways. That's great. So if this is, the last one was plus minus 2, this one should be as well. So let's try 9. Seems full speed, do 9.5. Yeah, 9 seems like the top. Let's try 8.5. I heard the pitch shift a little bit, so it slowed down just a little bit. So the other side of that should be 5 flat. 4.5, gonna make it go faster? Nope. So that's our range. We have a range of 5. Shush. We have a range from 5 to 9 with 7 in the center. Let's look at that code a little bit. I can show you. A lot of this stuff is just setting up the servo, getting it ready, and then this is just my example. This is the line that matters to you. So when you want to change something, when you want to change a rotation, direction, speed, you set something from 5 to 9 in here. And again, you can use some sort of interpolation to turn that into a minus 100 to 100 with 0 as stop. So if you do anything minus 100, it will go in reverse. 0 to 100 will go forward. That's typically how this is done. So you can set up numbers, and those numbers might be fed in from something else. So you want a scale of 0 to 100. And you can find that, how to do that, all over the place. We don't need to cover that one here. So there it is. We have modified the servo, and it works in Python. Awesome. So there you have it. We've modified a normal, typical servo for continuous rotation. These are great for uses as a robot drive motor or something like that, where you need a small package with the speed controller and everything all built in. Don't forget, there's a link in the description below for the parts that we're using, as well as a link to the GitHub page with all of the software that we've used here today. So now that you have everything that you need, go be creative and share with me what you've built. I want to see it. Not kidding. I want to see it all. So I can be found on Facebook, Instagram, Twitter, Patreon, YouTube, all the usual suspects. And if you like this video, please consider subscribing and ringing the little bell next to the subscribe button so you'll get notified when there's a new video. I plan on doing one every week. So until then, thanks for watching, and we'll see you next time.